Hi, everyone. Welcome back, Azure Cosmos DB Live TV. I'm your host, Mark Brown, episode 23, and going to talk about MongoDB API this week. I've got with me Gahl Levy. Hi, Gahl. How are you?
Hey, everyone. I'm doing great. Happy to be here.
Good to see you. Is this I think your first time on the show, isn't it?
Yeah, it's my first time. I'm excited. I feel like I was getting launched into space with that countdown. It was like
yes, that's right.
Very exciting.
We're going straight up out of the atmosphere right now. So hold your breath. Well, that's great. So thanks for coming on. I've been wanting to talk about our MongoDB API for some time. It's been pretty exciting what we've been working on for maybe the last year or so. I think largely since kind of you joined. I don't know what you did to those guys, but a lot of good stuff coming out that we announced at Build, and just kind of keep pouring it out. And so it's good to have you on to talk about it and talk to our viewers about it this week.
Yeah, we released 4.0 at Ignite back in March, and we have had great reviews of that. Lots of great use cases for that, and people are really excited about it. And yeah, happy to be here to talk about it.
Great. So let's talk about Mongo, I guess, in the context of Cosmos, because it's Mongo, right? Or at least we don't host the Mongo engine, right?
Exactly. It's not actually MongoDB. Right. It's Cosmos DB acting as if it's a MongoDB database.
Right. So emulating that endpoint and listening to Mongo protocol or commands come in, and then we do something with them and then do the work and then send the data back, right?
It acts as if it's a MongoDB database, but it's not. All the native tools work, obviously, but you get all the benefits of using Azure Cosmos DB, which is pretty neat.
Well, that's true. I mean, there are lots of benefits for using Cosmos. Elasticity is one of them, being like fully managed. Let's talk about it. I threw up your lovely kitty cat on the screen.
Yeah, I was planning on having the presentation be half cats and half technical, MongoDB API, that kind of thing. But we can talk about the API for MongoDB first before we move on to the cats, if that's all right. You mentioned instantaneous scalability, right? Should we talk about that first?
Sure. Yeah, let's talk about that, because I mean that's one of the biggest. It's one of the biggest selling points for Cosmos as a service.
Yeah, so because of the resource governance, scaling isn't an issue where you actually have to go and provision, additional VMs when you want to scale. Scaling happens immediately because we already have the resources there. So there's no waiting. In terms of like, if your users want additional resources, additional RUs, you get that immediately. And that's very, very unique to our service because we're a resource governed service.
That's right. So we're a multi-tenant.
Exactly.
Service, right? So everything is resource governed, which is why you have this thing called a request unit, right? Because it's essentially our resource governance around some bit of work, if you have in there. So it's a little bit of CPU, a little bit of memory, a little bit of IOPS, and then all kind of normalized into this RU thing that we've got, right? But behind that, besides just being an RU, it speaks that Cosmos is a multi-tenant resource governed service behind the scenes there. So
exactly. So as a user, I get the benefit of using my MongoDB apps with the API for MongoDB, but I get the instant scalability that Cosmos DB gives me. And when I have additional users that are suddenly using my application, I don't have to wait in order to give them the throughput that they actually need. It's immediately.
And we're, and we're native scale out, right? So you've got you're talking about the automatic and transparent sharding. I mean, that's in terms of the scalability, how we do it. You're not dialing up a VM, right? Or you're not provisioning a larger VM and then waiting for that to be ready.
Exactly.
You're just adding additional compute as a scale out. So you have to obviously support sharding within there, right?
Exactly. So we natively support sharding, and there's these things called logical shards and physical shards. And logical shards essentially map to the shard keys that you're using. And there's absolutely no limit on the number of logical shards you can have, which means we can horizontally scale infinitely, as much as you want, which is very, which is awesome. So for example, if you partition based on city, you can have unlimited cities worth of data there. And you don't have to worry about that because Cosmos DB under the hood takes care of doing that for you. You're not actually provisioning VMs and managing the sharding aspect. It's all done automatically for you by Cosmos DB. But as a user, I'm still using MongoDB. my MongoDB drivers, my MongoDB apps, all that is still the same.
Yep. Yeah, that's, I mean, you just, we're going to manage all of the physical aspects behind there, right? So you've got a logical shard or a shard of 20 gig inside Cosmos, and those sit on physical partitions or physical pieces of compute that can store up to 50 gig. And so as your logical shards kind of grow into that 50 gig, we'll split those, right, and add more compute and more storage so those things can grow to their maximum size within there. And that all happens seamlessly. I mean, you don't have to manage any of this. This is not right. There's no storage, nothing to manage.
Yeah, Cosmos DB is a cloud native database, so none of this needs to be managed by you, the user. The whole physical shards, that whole part here on the bottom, is invisible to you essentially, and you just have to manage which key you choose as your partition, as your shard key, and Cosmos DB does the rest for you, and you continue using the API from MongoDB and your MongoDB apps.
Yep.
Let's see. Somewhat related to this is there's because it's built on Cosmos DB, you have additional options in terms of how you want to run your workloads, which is pretty neat. It's an additional differentiator. Should we talk about the different provisioning options while we're here?
Sure.
Yeah. So we have standard provisioning, which is very, very good when you have a constant kind of workload, because as long as it's staying the same, you can be predictive of what it's going to be, and you'll save the most money doing it that way. So if you have something that's always kind of running in the same way, standard provisioning, which is something you choose on the collection level, is a great option.
Or if it's predictable too, right? Like if it's scale up at 8:30 and scale down at 5:30, that's also a good option too for that.
Yeah, you can do that programmatically too. Yeah, definitely. The other option is autoscale, which kind of goes to the instantaneous scalability. This is where you set an upper threshold on where you want to scale to. And in this case, you only pay for what you use, and you basically scale between 10% of that number and 100% of that number with no warm-up period. It happens immediately. The scaling is instantaneous, essentially.
So that's different than, say, Atlas, right? You have a lag in there, I think, when you do a scale up in Atlas, don't you?
There's no vertical scaling that takes place here. This is all essentially horizontal, but it's already done instantaneously for you. So there's no lag. There's no provisioning additional VMs, a larger VM. This is all built in natively to the Cosmos DB platform. Right,
and then for autoscale, you only pay for the most you use in an hour, right? So that's your billing window or your scale window, at least on the scale down, right? Like and what you said on the scale up, it's instantaneous.
Yeah.
So there's no warm up, no nothing, no lag. You got additional requests. We scale up and meet that need so you don't get throttled. And then on the scale down, that'll go back down in an hour, which is great because I think Atlas takes longer. I don't remember how much longer, but they don't scale back down immediately.
Yeah, exactly.
So,
and that saves you money too. And at the same time, it saves you money, and your users are as happy as they can be because they're not slowed down at all, zero whatsoever. Yep. So it's kind of like the best of both worlds.
Yeah.
Moving on to the last one, serverless, which is GA now for the API for MongoDB. This is great for very sporadic workloads, also dev and test workloads where you're just sending some requests to the database and then not doing anything for a week, for example. You're only paying for what you use, and serverless is pretty, to the point. And this is a great option for users, and we can offer this because we're a cloud native database. So
yeah, and it's recently the only cloud provider that had it. If I read my news correctly. So that's good. We've got different choices for different workloads and the characteristics for those. If you've got predictable workloads, the standard's going to be great for you. If you have unpredictable or just otherwise just varies widely, or you need to not have to worry about getting throttled, then autoscale is a great option. And then of course serverless, that's great for batch type operations, or like you said, dev test is another perfect one because if you're not using it at all, it doesn't cost you a single thing. And we've got those increased I think there's increased capacity in there now for that. I guess it's the same. It's Yeah, I don't remember what it was. I think we. Oh no, you know what it was? We increased the free tier.
Oh yeah.
That was another one. So now you've got like
1,000 RUs, right?
1,000 RU on there. Yeah. So
Yeah.
that's another. Yeah, we should talk about that free tier, right?
Yeah, that's separate from it. That's like you're not paying anything.
Yeah, you
We
pay
get no
nothing,
money
right?
for that at all. So
And 1,000 RU is a lot of compute. You can do a lot of stuff with 1,000 RU per second, right? So it's
yeah, a free database that you can use.
What was the storage?
Awesome.
They upped it to like 20 gig, I think now. So you've got
That sounds right. Huh.
something like that. So yeah.
Yeah. I mean, there's things that are just they just kind of make sense. Like 5 nines of availability. That's like something we can offer as an enterprise product here. That kind of speaks for itself, and it makes sense if you want your app to stay alive. This is a great option.
Sure. I mean, we have native regional replication, so we can survive regional outages, and customers can just simply fail over to any secondary region, which is how we give 5 nines of availability in there, which is, I mean, that's kind of one of our calling cards is 5 nines of availability. Customers come to us. Well, I mean, lots of reasons, but one of them is those 5 nines that's within there. So for sure, we can. Yeah.
And there's a few other things here I want to kind of talk about. I'm really excited about the last one. We have a demo about that, but I'll leave that for later. In the next bullet point, it says cost-efficient, granular, unlimited scalability. We had that slide where we spoke about partitioning, but I think the cost-efficient and the granular is very important because we're not actually provisioning individual VMs for each of our users for their databases. We're provisioning, imagine like 1/100th of a VM. We can scale at very, 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 very granular levels where other services can't because we're a multi-tenant resource-governed service. And that means you can very finely tune what you pay and make your database, your API for MongoDB database, very, very cost efficient.
That's right.
That's hard to do.
Like our minimum is 400 RU, which is about $25 a month. And then you can go in 100 RU increments, which is going to be what, like $6 basically. You're scaling up, something like that.
Yeah.
Help me with my math. I'm getting old. So, but it's cheap, right?
Right. Yeah.
So if you're paying 400 RU and it's $25 a month, you can go up 100 RU. Yeah, I mean, I don't know, $6-7. So,
Between 6 and 7.
But it's like a fraction of a VM that you're getting, or can scale up and down within there. So definitely very fine grained. And of course, there's a scale out, instant scalability.
And as you scale more and more, because this is a horizontal system, you want to parallelize your operations to basically take advantage of that. So you can scale unlimited, reads and writes essentially, and just go out more and more and more and more. And that's very unique because you can scale from start your app at a very, very small point. If you have a ton of users that suddenly join, you can scale out very fast and cheaply to where it makes sense for you and your business or your use case in general.
Yep. I have a question from a user here.
Sure.
I don't really know. What are your thoughts around pricing versus Mongo Atlas? Yeah, I don't know if we should comment on the pricing. I guess they have pricing as well. They're now in Azure. They're in multiple clouds. I guess. I mean, I would say look at the features that each of us is offering and figure out if the price points for either of those make sense for your workload. Other than that, I'm not going to comment on that. I'm not taking that bait.
There's also reserved. I think they mentioned provisioned throughput. We also offer reserved pricing, I believe, for provisioned throughput, which is listed on our pricing website, right?
That's true. So you can get pretty steep discounts for reserved pricing. 1 to 3 year period. Obviously, the longer you go, the deeper the discount, and the more you reserve in throughput, the deeper you go. I think it's like up to 66%, something like that. I think for the highest tier for 3 year. So 2/3 discount. That's pretty good. So yeah, I mean, I think our pricing is great along the whole curve, if you will, the cost curve. I mean, we've got free. We have an emulator that's also free, so you don't even need an Azure subscription at that point. And then you've got 400 RUs. That's your minimum provision throughput. You can also take and do 400 RUs and spread it across 25 collections in a single database as well, and run that all for 400 RUs. So that's another way you can save money. And then you add things like serverless and auto scale and reserved capacity. I think we're competitive with anybody out there for pricing. So,
yeah, and you can also set the exact number of RUs you want for your reserve, I believe. Yeah. So that way you're like you're putting it exactly like where you actually want and what you actually want to pay. Which is
thanks for your question, Daniel. Really, it's you're asking me to make a value comment on value for pricing, and it's really that's your decision really on there. So, but we're trying to make the best service for Mongo users and provide the value that we think they want. So, what does the upgrades take seconds? What does that mean?
Yes, I'm really excited to talk about this one because I have a slide for it. Let me go to this. Yes, this one.
Another key.
There's absolutely no content on here, just the same words with a different cat. So that's why. I can talk while this is on the screen. What's very unique about our service is that the API from MongoDB doesn't actually run any MongoDB code. And we're able to build it in a way where the code base contains all of the versions we support. All of the MongoDB versions we support are all contained in the same code base, meaning that when a user wants to upgrade from one version to the next, it's simply flipping up and down feature flags. There's no like long upgrade cycle that takes hours to complete, that you have to like do a rolling restart, any of that, none of that. It's just feature flags on or off. So as a user, when I want to upgrade, I just have to go in the portal itself and essentially change my MongoDB, my API for MongoDB version. And within seconds, my entire database would be upgraded. And if for some reason I'm not happy with the version, I can go back down with no harm to my data or database. Also takes a few seconds to complete. Your clients continue running, all with zero downtime. And this is very unique to like any database I'm aware of. It's very, very cool, and our users love this because it makes them feel very comfortable to upgrade or downgrade from new versions and see how it works, and then make a decision where they want to be.
That's cool. Can you go backwards and forwards? You can go from 4 to 3.6 to 3.2 and
exactly. Yeah.
Wow.
4 to 3.6, and
okay.
I had another point on this as well, but it's like basically it's a very, very low risk, upgrades. And upgrades usually is such a big deal for as an operator. This is a much, much more seamless way of doing things, which is great.
This is cool. You could have one of your test instances or whatever, hydrate it with data, flip the switch, run your unit test or whatever testing you're going to do, see how it works, and then make the call like, hey, let's do it. We're ready to go. So yeah, that's really sweet. And it's also, that's interesting. We run every version on the same code base. So so we've got 3.2, we got 3.6, we got 4.0, pretty much all running on the same code base. And that's pretty awesome.
Which actually brings up another point that you're kind of hinting at there. As an engineering team, it makes it much easier for us to maintain older versions because it's all in the same code base. So we're not, with each additional version, it's not like we're maintaining an old code base we have to drag along with us. It's much easier for us to keep older versions around because of this architecture, which makes our users who want to stay on the version that they're happy with, happy because we don't deprecate it and take it away from them.
Oh, that's interesting. So maybe if there are Mongo users that are running 3.2 that would like to move to the cloud, I guess we may be the only game in town for them, I suppose, right? So
that's end of life. So yeah.
So we're there for you, I guess, right? Because we can
essentially we're there for you. This cat's also there for you. The cat can also upgrade your database for you. It's literally a one button click in the portal. Like I was showing you, you can also do it programmatically too, but it's literally, you just go here and you set it. We call it setting the version because we're not even upgrading it. We're just setting the version. That's how easy it is to do.
You know, you should have had a GIF of a cat like pawing at a button or something like that, and that's like the upgrade button right there.
That's the next iteration of the slides.
Is that the next version? We need to get some designers, I guess, to help us with those. So
yeah, I have the same thing here, basically. But yeah, same exact thing.
So that's the upgrades take seconds. That's also very cool. The other thing that I liked as well that I saw on the screen there was the server-side retries. That was another thing where I know we'd had customer feedback. So, and it goes back to that we're a multi-tenant resource governed service, right? So unlike running Mongo on a VM, where if you start hammering the VM with request, it just starts building queue depth. Basically, the requests just keep piling up, and you see latency as a result. With a service like Cosmos, we don't behave that way. We accept requests up to a certain amount, and then we just throw 429s and say, nope, too many requests.
Exactly.
And that frustrated, I know, a lot of folks, particularly when they were trying to do like loading data, or I don't know, or they were running some long running operation or whatever like that. It didn't behave the way they were expecting in there. So that's where the server side retry came from, isn't it? Where it basically kind of emulates the behavior for how a VM would feel if you were piling requests up to it, because it's going to just queue those and then keep retrying them on the server, right?
Exactly. So we essentially give users the option: do you want to have those essentially guaranteed sort of times, basically, where in terms of latency, where once you filled up your pool of resource units, we start throwing those 429s and not letting those extra additional requests go through. Or if you want it to behave more like a VM, where we just retry it and the latency on those requests goes up, but they go through and you don't have to handle that in your code, in your client code.
Well, you should have something catching.
Yeah, in general you should, but like this is an additional layer that helps.
Whether it's poly for C# or something, right? If you're anything that's going over a WAN, you got to be cognizant of transient faults and other things that can happen, and have retry logic or other things in there. So yeah, so that's another thing I really thought was cool that we were doing or had done recently in there. And then the continuous backup, I see that in there as well, which is kind of a new thing for us. I think we announced that at Build in preview. And now we've got that available for Mongo, I see as well, huh?
Yeah, so essentially what this gives you, instead of having to take periodic backups at certain time intervals and being able to restore to those time intervals only, with continuous backup, you just set it and forget it. You can essentially restore, as long as it's on, you can restore to any second within your retention period range. So for example, in the last 30 days, I can restore to any point in time without having to take a specific backup at that point in time. Just within that 30 days, the window, I can restore to any second. And this is just a usability thing and a peace of mind feature. You won't be left at a point where you can't restore to somewhere you need to be.
Yep. Yeah.
Yeah.
Very cool.
What
else you want to talk about in here? Any other goodies?
Well, I'm really excited about the Synapse link. I wanted to leave that for last. I'm thinking if there's anything else I wanted to talk about. We can chat briefly about the 4.0 release, just the main benefits of that for anyone that might be on 3.6 or 3.2.
Yep.
So we recently, back in March, we released 4.0 support, which kind of gives a big feature to users, which is the multi-document transactions, and allows you to basically take couple operations together to a point where if one fails, all of them fail, which is great for like operations. For example, if you're taking money out of one person's account and putting it in a different account, you don't want one to succeed and all of the rest, to fail. You want them all to succeed or fail. That's like a big feature of that. The second thing is the aggregation function support. There's additional aggregation functions that support. They just make the pipeline better and easier for people to use, and just compatibility with tools that only support 4.0 and up. And the last thing, which is maybe not as glamorous, but it's very, very important, is just efficiency and performance gains. There's a ton of work that went into making queries and storage much more compressed to a point where people can save, a double digits percentage on queries and on storage just by upgrading. Just simply upgrading and clicking that button and moving to 4.0 will just save you money immediately, going forward, which is
right. So we did
awesome.
a ton of work on our storage backend as well. Very good in terms of the performance. I mean, it's interesting. The compression is so good on there that it's noticeable, not just in storage, but now things are faster. There's processing is faster, requests are faster, the payloads are lighter. That's pretty awesome. The work.
And what's unique is in Cosmos DB, in the API for MongoDB, faster also means cheaper, because that just translates directly to request units. So you're saving money. You're getting something faster and saving money at the same time. So it's correct. A double benefit.
The payload, the less CPU and memory and IOPS you need to process the request both ways. So kind of a two-part question from a viewer here. So can you explain automatic versus fixed RUs from the perspective of scalability and performance? When asked to kind of clarify, trying to provision Cosmos and prod and looking for better understanding of the automatic RU over fixed RU. I think they're looking for fixed collections versus sharded collections.
Oh, so not the throughput.
Well, I don't know. Maybe Swapnil, if you can clarify. But why don't you talk about that?
The fixed first
later.
Yeah. So fixed collections essentially are bounded to a certain size. So 20 gigabyte is you have a fixed collection, and you're bounded to that. I think that was recently raised to 50 gigabyte.
We're still at 20. I think we're still at 20.
That's physical partitions. Confusing the two. Yeah,
so physical partitions. Maximum 10K RU, 20 gig of storage, and that's it.
And the underlying,
you get, right? Because if you don't have a shard key in there, we don't know where to direct your request. So you get basically one logical shard, 20 gig, 10K RU, and that's it. That's basically
and the one benefit is it's very, very simple, and you don't have to shard it, and you don't have to worry about to use a shard key at all. But at the same time, it's fixed, so you can't scale out past 20 gigabytes. So you have to really think about your use case before choosing to go with a fixed collection. It is also useful if you are running multi-document transactions in 4.0, because 4.0 only supports multi-document transactions within a fixed collection. So if you have a use case like that, fixed collection might be a good idea as well. Sharded, on the other hand, is kind of where a lot of the scaling on conversations take place, because once you have a shard key that you pick and you have a sharded collection, you can scale infinitely horizontally and really serve your users with as much throughput as they need.
You know what? I'd say out of all the conversations I've had with folks about this topic, and then they asked about kind of those difference, and I explained, I'm saying, you should just go and just create a sharded collection now rather than do fixed. I said, there's nothing more painful than having to go and copy this stuff into a new collection that's all sharded. And they're like, nah, I'm going to be fine. I'm fine, right? And I would say maybe almost a third of them come back later at some point, like a year or so later, and they're like, yeah, I wish I'd done that sharded, because not all of them needed it, but there was always like a collection or two that grew unexpectedly, and they ended up having to copy it into a new sharded collection. So it's painless, right? That's why we make it seamless, right? So that it doesn't have to be painful to do. You just put some thought into what you would like that to shard on, and then forget it at that point. Well, I mean, don't forget it, but
as long as you choose the right shard key and you're aware of as with all databases, including MongoDB, every NoSQL database, you have to understand data modeling to an extent. But choosing the right shard key, putting that in ahead of time will get you to a much better place as you scale. So
Swapnil, I hope we answered your question there, sir. Thank you very much. So, okay, where were we? We talked about automatic upgrading. Let's
It might be
see.
time for a synapse, almost.
Yeah, or
And
you want to just
here.
show kind of connecting up using Mongo Shell or whatever, or did you have any?
Sure. By show you mean demonstrate, right?
Yeah, sure. I mean, people want to see is like, hey, is this real?
Of course.
Can
Yes.
I actually use my favorite tools?
Yeah. So what's important to note is that essentially the API for MongoDB acts as if it's a MongoDB database. So your native tools will still continue to work. And as an example, I have a Mongo shell opened up here. I just connected to it using the connection string, which I can get from here in the Azure portal. And just like a MongoDB database, we respond in the same way. And I've already created a collection and a database. And the database is named people, and the collection is named New York City. And right now we can see I have no data in this New York City collection, but I'm going to add some data to it. Insert 3 people into my collection. And just as if it's a MongoDB database, the API for MongoDB responds in the same way.
It's just like it, right?
So except this gets stored in Cosmos DB, which is awesome. And just to show how this goes from tools, so this is a MongoDB. This is a Mongo shell. We can go to the Data Explorer and actually show that you can see our collection here. New York City, you can see there's documents, and those documents we inserted should show up, and here they are. And you can access them from here. You can access them from any of the MongoDB drivers, like PyMongo, for example, and use the tools you're used to using, and keep your app as similar as possible, but just build your app using MongoDB, but on the API for MongoDB built on Cosmos DB instead.
Yeah,
very, very similar.
I mean, that's that's what we're trying to do. I think is just use the tools you're familiar with and comfortable with, and bring it on over to Cosmos. And
get all those benefits that we discussed too.
Not just that, but as a native Azure service, we've got great integration into all the rest of Azure as well. And that's if you're already bringing it over to Azure, why not put it in a database that you can use and trust, and also be able to take advantage of all the other points of integration within there. So yeah.
And that's a really great point. I feel like you're hinting that I should that it's time for me to talk about one of my favorite features. Is it time? Was
I obvious?
A little bit obvious. I was like, I'm gonna say it right now. I have to tell them.
This is my probably most favorite feature for Mongo right now. I've been salivating over someone showing this for a long time. So
there's one key point that I left out of this data insertion. This collection has actually had our Synapse link enabled, and I'll talk about what that means. So imagine you're running your transactional workload on your transactional Cosmos DB database using the API from MongoDB. Sometimes you want to run analytics on that data, but you don't want to impact your transactional workloads. You also want to run these analytics in a fast, cheap, and efficient way. We now offer what's called the Synapse link, which allows you to, basically, it works as a checkbox. That's how simple it is. There's no other way to put it. It's right here. The checkbox is on. And then you click another checkbox in your collection. And with that, the Synapse link automatically takes your data out of your transactional work store in real time. I think it's up to like
30 seconds, I think, is the max on there.
Yes, something like that.
Yeah.
And replicates your data to the Synapse workspace and stores it there at, I think it's like 10x or even more, like cheaper, very, very, very cheap storage, and allows you to perform analytics queries on that whenever you want in a very, very cheap and efficient way, because it's a column-based store. Yeah. And as we just saw, we inserted data using Mongo shell. This data appeared in the Data Explorer in the in the portal. And now we're going to go to the Synapse Analytics workspace, where we're going to run a T-SQL query against this API from MongoDB data. And hopefully, if everything goes well, since it's a live demo, we will see those exact documents we just inserted appear in Synapse, and I access it using a T-SQL query, which you can use as well to use this language to query your data fast and cheap. And you don't have to worry about this impacting any of your transactional apps or your workflow whatsoever. And this is there's no ETL on your part. It's all done automatically.
That's right. So it's true HTAP, right? You're only paying to insert the data into Cosmos. There's no cost for it to automatically ETL into our column store. Mm-hmm. But the mind-blowing thing is I can have MongoDB as my operational OLTP data store and then write T-SQL queries on top of MongoDB data. I just love
it. Essentially in real time too. If I go and delete this data, it will disappear from here, and we can do that again over and over.
Or I could run Spark on there too. We support Spark engine as well in there. So either of those two, but I mean, mind blown, right? I can go and I can write T-SQL queries on top of Mongo data and do analytics on that. I can do ML on it. I can visualize it in Power BI. All the things, all the goodness that Synapse, all our analytics platform provides is right there for you. And that's powerful, right? That's the integration that you just cannot get anywhere else.
The Azure ecosystem, just like what you were saying before.
Right.
When you were lightly hinting that I should talk about this as well. But
I
was going to talk about it anyways.
Well, right. There's lots of places of integration in there.
Yeah.
Right? So, we integrate into Azure Search as well.
Essentially, you're using your MongoDB native tools, your MongoDB apps, but you're integrating with the Azure ecosystem, the Azure platform, and the Cosmos DB platform. So you get all those benefits and additional benefits that we're showing you here as an example. So it's pretty exciting. I'm really excited about this.
I'm super excited by it. I think this is just great. If you're coming to Azure and you can access powerful analytical tools like this with your MongoDB data and get new insights into this, I mean, there's so many benefits to moving into the cloud in the first place. This just goes above and beyond just what you would expect for this type of for what we can give you. So, yeah, super exciting, super exciting.
Yeah.
Anything else you want to show or comment on before where are we at with everything here?
So I think I have one last slide I want to talk about regarding takeaways, and then we can talk about how to get started essentially. Just main takeaways when using the API from MongoDB is that we are a multi-tenant, resource-governed database. You are not built for virtual machines, so it's really important to get out of that mindset when using the API from MongoDB, because it's different and there's a lot of benefits with that, but it's still it's a bit different. But most importantly, you can continue using your MongoDB applications and using all of the things about MongoDB that you actually love. So you're kind of getting the best of both worlds here. What else is important? Yeah, we talked about this, but just to reiterate, there's provision throughput, there's autoscale, and there's serverless. There's 3 different ways to run the API for MongoDB.
And free.
Yeah, and free should be, free should definitely be on there, but yeah, free is the big one too, and lots of people love that. And lastly, it's important if you want, it's recommended to start with a sharded, the shard key and the sharded collection, unless you need a fixed collection for various reasons. But it's good to start with a sharded collection, and it's important to choose the right shard key. So make sure to think about that and data model before you go ahead and do that and start there. And a great way to get started, that link was just shared, but we have documentation talking about, which is a great entry point to talk about the API from MongoDB and what you need to know to get started, kind of reiterating all the points that we discussed today. And you can go straight from there to the portal and Azure portal and provision a new API for MongoDB database account and databases and collections. So we're really excited to hear.
Do we have those new quick start? Is that new quick start up there?
It should be. We have quick starts under here, under the documentation.
.NET one. I wonder if that one that we saw is on there. So you want to take a look at that one?
Yes.
2021. I think so.
I think so. Yeah. We have quick starts, and there's a lot more coming, and
that's
it. Just makes it easy.
Using .NET 5, not .NET 4.7.2 from like 1980. So that's good. It's using a relatively recent version of .NET. So yeah, we've got folks a brand new MongoDB quick start for .NET. We'll do more as well, but we've got a new one there. Definitely feel free to go check it out. Also, there's I believe a new one over on the .NET side, a web API one for Mongo. That's also brand new as well. So go check that out if you want to see some cool new startups or quick starts for MongoDB. The other thing I want to point out as well, the other area where this is better integrated into Azure is all the management in there. So, there's full support for all of the ARM capabilities and features within there. So if your DevOps folks are clearing, they're like, I need ARM templates to do all this stuff, or Bicep, that's all fully supported in there, and lots of samples. I should know because I wrote them. There's also support for PowerShell and CLI if that's your bag. Terraform, Halloumi, Ansible. So all of those things all supported within there as well, so that you can manage all your DevOps as well seamlessly within there. So anyway, just plug in all my stuff. I did a show on all the ARM stuff I work on. So
yeah, I feel like I should just change the slide to say the API from MongoDB is so easy a cat can do it, rather than just upgrading. And that would kind of summarize my thoughts on
right.
On the database.
It's fully managed. That's the whole point. Is make it easy for you, so you don't have to manage VMs or clusters or any of that stuff. So.
And I should also change this to a GIF, like you mentioned. So I have some homework to do after this presentation, but that's what it sounds like.
Just go to Giphy and find a cat pushing a button like this. Or whatever.
I don't think that your viewers want to watch me do PowerPoint right now, especially live on.
Hey, we do live coding on this show. That's okay. It's not a problem. You can do live PowerPoint on this show.
Yeah.
No judging. So. All right. Is that it for today then?
I think so. I'm really excited to hear people's feedback and hear more from people.
Check out our docs. Check out our new quick start samples and give it a try. I mean, it's free to start. So, there's no reason to not give it a go. So thank you, Gahl, for joining us this week. Great having you on. I cannot wait. I'm sorry. I promise we're gonna have you back on before the end of this year.
Love that, yeah.
Because I think there's gonna be more stuff you're gonna want to talk about. Is that right?
There's always more.
Okay, exciting stuff. I cannot wait to have you back, and I can't wait for our viewers to see you as well. So, thanks again, sir.
Thank you so much.
Well, that's it for this week's show. Just a few announcements. So starting a new Azure Cosmos DB virtual global user group. We'll do monthly meetings online. Our first meeting has already been scheduled. It'll be yours truly talking about how to model and partition data in Cosmos DB. Wednesday, September 22nd, 2 p.m. Pacific. That's 10 p.m. BST and 7 a.m. AEST or Sydney time. So come check us out. I'll be giving away maybe 1 or 2 of these lovely coasters, neoprene Cosmos DB coasters. This one's already dirty because I put coffee on it. So I think I better get a clean one out of the box I've got. So come and join us, and we'll have a drawing for a couple of those fancy coasters. Also, coming up September 29th and the 30th, Azure Serverless Conf. So the Cosmos DB team has teamed up with the Azure Functions team, Logic Apps, and also the SQL Serverless folks. We're going to have 3-hour live streams for Americas, Asia Pacific, and also EMEA. as well as, I don't know, about a dozen, 15 or so on-demand sessions. We're just through picking all the sessions for both the live streams and the on-demands, and it's going to be a great lineup. You're going to definitely want to check it out. Great keynote, too, from some folks I think you all know. So that is AKAMS/Azure Azure Serverless Conf. Go there for more information or to register. And then show ideas. If you've got any show ideas, just hit us up on Twitter at AzureCosmosDB.com. I'll see your tweet there. And thank you very much for suggesting new topics for us on our show here. So next week, taking the week off. It's our end of summer, I guess, holiday week, Labor Day, right, Gahl? Next week. I think most people, since it's kind of the last gasp of summer, well, I don't know. It depends on where you live. Summer here lasts until like Thanksgiving, so that doesn't apply to me. But in places like Seattle, at least, or in many parts of the country here in the U.S., this next week is our Labor Day week. So Monday's off, and typically people take the whole week off. So we'll take the week off, even though I'm still going to be working, actually. But when we return, we're going to have Abhinav, who was on our show recently, talking about the Confluent connector. He's going to come back and talk about all of the new client-side telemetry features in our Java SDK. Some very, very cool client-side monitoring, performance monitoring capabilities that are in there. So good goodness within our Java SDK. So join us next week for that. And I guess with that, Gahl, thank you so much for joining us this week. And thank you, everyone, for watching. We'll see you in a couple of weeks.
Thank you.
Thank you.